I think that's probably what, if I was a student, that's one of the main things I'd want to know. So this test is on chapter 5 and 6, but don't forget it also covers section 3.4 with the box plots from a long time ago. Oh yes, that's why there's a box plot problem on the practice test, right?
Do we even do this practice test?
Say it?
Do we have a practice test?
You should have one. Who needs a copy? Hopefully I have enough.
Do you?
Do you?
No, I
You don't? What's that?
don't. I have it.
You have it.
Oh, that. Well,
Oh shit. One of these. No. So very quick statement about the practice test. Number 8, I think it is.
Is not happening?
Yeah, that last, I can't remember if I said that last time or not.
Good.
Good. I like it. So just in case you missed it, number 8 will not be on this test. We didn't make it into chapter 7. So there won't be any chapter 7 on this test. I'm not that evil yet. Give me a few more years. And then we're like, y'all do it on your own. Yeah. What do you think?
No.
Okay, good. Go ahead, you got in that one.
Well, it says on the tentative schedule.
I know, tentative schedule, so now we're adjusting it as we go. I would never make homework do that I haven't lectured on. That is part of that evilness that I don't have yet. Yeah. I'm a math teacher, give me time. So, section 3.4 really didn't have formulas unless you want to put down, like, it's finding the percentile, so you can make that box plot, finding the quartiles, percentiles. Do you vaguely remember that? There is a formula they have in the book, and it all depends on if you want to use it. Personally, I wouldn't do that. All that's really saying is, if I want the 30th percentile, I'm going to take 30%, 30 over 100, 30%, of how long my list is, and then go find that, right? So if you get a whole number, what do you do? If I do this work and I get a whole number?
Average.
Yeah, so if I get 7, the answer is going to be the average of 7 and 8. If I get anything else, if I got 7.03, the answer is the 8th number, 11. Is that coming back to us? Yeah.
Exactly. Two things. Which number are you on, or are you even doing it?
I'm doing sort of doing a formula sheet.
Okay, that's
Yeah.
better. Also, what's K? I didn't remember that at all.
Yeah, I didn't write this down, but in case you want to put a formula on your sheet, this is it. My recommendation is don't. Because we know the process, and this might freak you out on a test. You're like, oh, what the? You have the same question you have right now. What the hell's K? K is a variable that represents whatever percentile you want.
Oh.
So if I want the 72nd percentile, what I do 0.72 times how long my list is?
Yes.
And isn't that 72 over 100, 0.72? So that's a formula that kind of shows the first step in the problem. But my recommendation is, don't put it down.
Okay.
Yeah. So far we have 0 formulas. Very productive, Jeff. So in chapter 5, what was chapter 5 all about?
Statistics.
All right, so your formula sheet is just going to have vague references. More stats, more stats. It's not helpful. Just a little more specific.
Discrete probability.
I like that. So somebody's check one through. So remember it was the one with the x, the p of x? So I've got to give you the table. The funny thing is the formula tells you when you should use it. You use this formula. Anybody remember what the mean is? That's for binomial. For an x p of x problem.
The sum of x. Of x.
I like it. Remember the first 3 letters? is the other name for the mean.
L2.
Expected value, EXP. Remember that?
Oh, yeah.
So when I ask you to find the expected value of something, this is what I mean find the average method. Okay, cool. So a couple of problems in the homework said find the expected value of the insurance or whatever it was, or the lottery. That's what all it meant was find the mean. Standard deviation.
X2 P of X minus.
Yeah, x squared P of X. Mean squared, I love it. Cool. All right. So when do you use those? When you have these. You can't beat that. When do I do this? Oh yeah, when I have those. Then I do this. Cool. So that's the stuff for any general probability distribution where I give you X and I give you P of X. What about for a binomial distribution? You already told me. What's the mean? NP. What's the standard deviation? Root NPQ.
Can we differentiate on the notes or no? Can we put like
You can't
by
title.
next to it?
No.
Okay.
Don't do it. Bad idea.
Wait, so the first one before is for discrete, you said?
Yeah, this is for any general probability distribution, and it does have to be discrete. Because these X values have to be something I can denote in a table. If it was continuous, ain't no damn way. My table's infinitely long. That sucks. So it does, you're right, it does have to be discrete. Binomial definitely is more obvious it's discrete. I can have 0 people that like chocolate ice cream, or 1 person that likes it, or 2 people. Cool. No problem. This would be the number of TVs and the probability somebody has those TVs. So I don't care how bad your TV is, either it's a TV or it ain't, right? You'll say, I got 1.7 TVs. I got 2 of them, but one of them doesn't work all the time. No. And what's the probability formula for binomial? I love it. So N, choose X,
Times
Cool.
probability P times Q.
Q to the N minus X. And this is the part of the formula that will throw you off, but all that's trying to say is the rest, right? If I have this many successes, the rest must be failures. So don't make a big deal out of that N minus X in the formula. Formulas always look a little harder than it really is because they have to be the most general statements. Okay, cool. So don't knock formulas for the hard job they got. So this is chapter 5, the beginning. This is the end of chapter 5. And then we get into chapter 6. And really the only formulas you need for chapter 6, what do you think? Now just to be fair, you could draw lines, Brendan. That's fine, so you can draw a line. And do it in order. 5, 5, and then here comes 6. Right? Okay, but no titles. You definitely want this formula down there. Does that make sense? So that's section 6.3, really. 6.2 is just practice with the chart. 6.3 is here's X scores, make them Z scores, and then use the chart. 6.4 is the freaky ass section that we might talk a little bit more about in a minute. There's no formulas from that really. The formulas from that are used in 6.5. And what are the formulas from the central limit theorem? Or what is the formula, really? Central limit theorem. What does that bad boy say?
Sigma of some, I don't know, can't even say it, but it's that.
Gotcha. The new standard deviation.
Yeah.
The new standard deviation is equal to the old one divided by square root of n. I love it. Okay. Alright, it's a little better. Do you remember this? When do you do this? 2 things. When do you do this? When I take a sample and I ask a question about the mean.
And it's more than 30 or something else?
Say again?
And it's more than 30? Or?
Good. So what's the central limit theorem say? You can't write that up here, but central limit theorem says several things. The larger sample you take, the more normal the thing approach. And when you hit more than 30, then you can assume it is normal enough. I love it. So that's really what it says. These are kind of offshoots. It says the mean stays the same. Mu sub x bar equals mu. It stays the same. But the standard deviation gets smaller, and that only makes sense. The samples I take will be closer to the average than any individual would be. So my standard deviation should get smaller. They're all getting closer to the mean. Hopeful. Remember the ages in Florida example. Okay, always hopeful. So you know the kind of problem I'm gonna give you here. You know I'm gonna give you one much like the homework. I'm gonna give you like a normal distribution and say pick one person. Okay, that's a straight up make a z-score, look it up. Now pick 18 people. Oh crap, he's taken a sample. What's the problem with this? Average is blah, oh, he's asking about the averages. I better change the standard deviation and then do the z-score. I don't know what all my,
But
all my
if it were
pages.
18, you would have to tell us it was normal.
Yeah, I'd have to start off, and that's what I did. It'd have to be normal to begin with. Why would it have to be normal to begin with if I take a sample of 18?
Because
It's not bigger than 30. It can't be normal just on the basis of the sample size I'm taking. It has to be told to me that it's normal. How are we doing so far? Okay. I got 4 people shaking their head yes, and I'll take it, yeah.
I'm feeling extra dumb today, I guess, but can you just go through this and like do the?
Yeah, as soon as you get the formula sheet done, we'll start doing specific problems. The only last thing from chapter 6 is not really a formula you could put down, but remember the very last thing was the nav, the normal approximation to the binomial distribution, right? And that was sort of like this. One tweak, everything else is the same. The nav, I go up and down, up or down by a half, and then everything else is the same. Look up a z-score, find the area. There's no real formula you can put down here, right? And Jeff is going to be very nice. I don't want to start talking about myself in third person, too bad. I'll be very nice and put down there, use the nav to blah, blah, blah. That should tell you that's where you want to do that continuity correction. All right, so we'll do some examples of that. Anybody have any other suggestions what to put on there? Anything I might have skipped on?
We can't put n is greater than 30?
No,
Okay.
not a formula. It's a test. And what is it from 6.6? The test for 6.6. Central limit theorem says size has to be at least 34, or greater than 34 to be normal.
PQ has to be greater than or equal to 5 and P, or NP and NQ.
Beautiful. NP and NQ have to be bigger than 5. There's always some kind of test. When I have a new distribution, there's got to be a test to see when is it normal enough. And why is that so important? Because if I know it's normal enough, a lot of my work is done. The whole chart, work done. If I don't know it's normal, oh shit. I've got to do all the work myself, and we don't even learn about that work in here. That gets a little bit freakier, right? That's stats 2 if we offered it. Okay. Is there anybody else, any other suggestions what to put on there? I'm surprised. Normally I get more suggestions. Oh, it's open. This, no. So no notes, no words, no weird little shortcuts you devise yourself, shorthand for yourself. I love it when I see something and I figure out, oh, that's what that is. No. So no creative ways to write notes. Yeah. Okay. Let me do this. I'm going to kind of work backwards. And I want to do a couple things out of 6.6 first.
Okay.
And then we'll kind of work our way back and see where I'm in trouble. 6.6, for example, number 18. Okay. So this is 6.6. So take a look at number 18. If you've done this homework yet, these problems, and I'm glad somebody came to see me this morning, and this is why I always stop for homework questions, is this section I always forget that they don't really give good examples for this kind of problem. Right? This section doesn't really show you a good example of this. You're kind of left on your own to figure out what to do with it. Which is not easy when you first learn about the damn thing. So I want to show you how to do this kind of problem. So read through number 18. All Now, the problem with this problem is that they give you two separate probabilities, and that's because of what happens in real life. We'll see something in real life, and then we want to test it against something else. So if I wanted to see, maybe this was not the better one to start. I should start with the light detector one, but too bad. If I want to check, so what did they actually observe happen? What did they see happen?
2060,
Yeah.
or 73%.
Good. So they saw 2,060 people that said they use the internet, right? So there's a claim that's made. This technologist claims that 75% use the internet, right? Okay, you with me so far? Okay, cool. So I want to check to see if this claim is correct. And the way that I do that is, if this number was right, how many people should I have found? How many people should I have found? And what's the total number of people they looked at?
2822.
2822, I love it. So they looked at 2,822 people. They observed, what was it, 2,060?
Yeah.
Yeah, or 73%. They observed this many. Now, if this 75% was correct, how many people should I have found something close to? What's the expected value?
MP.
NP, the mean. So what is the mean in this case?
I got 2,116.5.
Oops, what was it, 2822 times 0.75. Do it again.
2,116.5.
So here's the idea. Here's the mistake students make. They use this number, the 73%, as P. No. We need to assume that this is what it is, and then see if this is crazy compared to that. So when I go to flip a coin, and somebody says, my coin is weird, it has too many heads. What's your assumption going in? How many heads would you expect if I flipped it 100 times? You expect to see 50. So you go in, you're going to compare what you see with what you expect. And then you're going to see if it's freaky. So if I flip it 100 times and I get 10 heads, you're like, yeah, something weird with your coin, man. It's far away from what I thought. So I need to set up the idea with what would it be if it was 75%. So then P is 0.75. Q, of course, would be 0.25. N is the 2822. So what would the standard deviation be for this case? What would the standard deviation be?
23.003.
Yeah, so that's square root of 2822, 0.75. Is that cool, everybody? Just plugging stuff in? Do it again, sorry.
23.003.
Cool. Stay with me. Okay, so if the 75% is true, then the mean would be this, the standard deviation would be this. So the question really is asking, and is my, real quick, I'm going to ask you this, is my NP and my NQ good? But my NP is 2116, is that okay?
Yeah.
Because it's bigger than
5.
5, check.
Or equal to 5, right?
Or equal to, yeah. I always forget, depends on the book you use. NQ would be the rest, which would be 705.5, I think. Is that right? Somebody do that? To find NQ, you just take 2822 times 0.25. And I think it should be that. Whatever the hell it is, it's around 700. That's bigger than 5.
Yeah.
How are we doing so far? And why the hell did I just do all that? What does it tell me I'm allowed to use now? It's normal, so I can use Z-scores to look up areas.
Oh, that's what it is.
Cool, I like that. So here's the situation. Now this, I really want you to understand that this is a problem they've put in here because we have all the tools to do it. Now the problem with this is some of the concepts are still a little new to us for this problem. This problem is difficult. And it's actually at chapter 8. All of chapter 8 will be problems something like what we're about to do. They're not all going to be binomial, but they're all going to have the same idea. And let me see who remembers from last time, because again, this is a really freaky ass idea. If I flipped a coin, and we did this last time, if I flipped a coin 500 times, if I got exactly 250 heads, you guys told me that would be a little bit weird, right? In fact, exactly anything would be a little bit weird if you think about it. But to be fair, would I say that 250 is unusual? Hell no. Because it's not far away from the mean. The whole idea of that unusual, that 5%, is that it's more than 2 standard deviations away. For the moment. Anyway, chapter 8 will get more possibilities. But right now, it's more than 2 away. That's unusual. So I can look at z-score up and all kind of stuff. But really what I want to do here is, here's the mean. Do it, Jeff. And here's what we observed 2060. And this is where I think I told you a little wrong, because I had in my head that it was on the other side. So that's my mistake. Don't worry. Because I was just... I want to see if getting this or less, I want to check what area is this in. Why would getting like 2117 not be weird? Why would that not be unusual? Because there's a lot of stuff here, right? I want to check how much stuff is in the area where it is. There's more than 5% in there, isn't there? There's a lot of stuff in there. So here, how do I check to see if that's unusual? I check to see if this, how much area there is here, to see if it's really unusual.
How much area would be unusual?
Tell me. You know.
Good.
Less than 5%. We've known that, right?
Oh, right.
Good. So that's the connection that I haven't made yet. We knew it was less than 5%, but now I can look at it as an area the same way. Areas are probabilities for pictures like this. So if I see less than 5% that this, where this is, if I see less than 5% below that, then I know that this would be unusual. It's evidence that this is wrong. So let me really set the stage here. If this is right, I should get something close to this. Are you guys with me on that? If that's right, I should get something close to this. I need to figure out, is that close to this? One way to do it is just to look at the z-score alone, and I'm with you, but we're going to go one step further than that. We're going to look and see what the area is, just to further confirm it, because that'll be what we're doing in chapter 8. Yeah.
I did the min and the max, because that's what we had done before to confirm if something was unusual, and found that it was more than 2 standard deviations away. So
Gotcha, gotcha.
Do you want us to go even farther?
I want to go a little further, because and the clue for this is it's in section 6.6. You should use this somewhere in the idea. And they're really trying to get us ready for chapter 8. Right, so,
okay.
All right, so I'm hoping that you guys are semi with me. So if I want to know if this is unusual, I want to know, and here's the mistake I made with push, because I was thinking about the other side. I want to know, would it be weird to get something at most this? Would it be weird to get at most that? That's really the question to make it fair. Any specific number would be unusual in itself. Any specific number would have a very small probability. So it's not fair to do that. I want to see the area it's in. Anything in here is not unusual because it's in an area with a lot of stuff. So what's the area this is in? Let's see how much stuff is down here. Okay. All right. So if I want to know this, what do I have to do with this number?
Continuity correction.
All right. So draw a little box. If I want to be less than or equal to that, which side do I want to start on? This side or that side? This or that? That. Because I want to shade down, do I want to include 2060?
Yeah.
Yeah, so I want to make sure that I shade this bar in as I go, so I've got to start here. And what is that?
2060.5.
Hello. So then you make a z-score out of this. Now that by itself would actually be enough to stop, in general really, but I want to go one step further and find the area. Because if you look at the back of the book and you're checking your answers, they always reference 5%. Is it less than 5% or greater? So this becomes that. Then make a z-score out of that thing. How do I make a z-score out of that? Yep, so you take that score. You do it, Jeff. Minus the mean. Divided by standard deviation.
2.45.
Thank you. Negative, right?
Yeah.
Negative 245. So that by itself kind of confirms, Brandon, what you were saying. That's more than 2 steps away. Down in this case. That by itself tells me that this is unusual. What's the area though in here? What's this area?
It's
So if you look up negative 245.
0.0071.
0071. How does that compare to 5%?
No, it's less.
Yeah, 0.0071 is less than 5%, less than 0.05. So let me wrap this up. What the hell did we just do? That's a really good question to ask very often in this class. What we did was so unusual, was so unlikely, if this is true, that this is probably not true. That's the whole idea. And that actually is chapter 8 in a nutshell. Right? Well, you don't know that. I can't say right. Whatever, Joe. Chapter freaking 8. Huh? But that will be what chapter 8 is all about. Is this enough evidence? Is what we saw enough evidence to say that, no, dude, you're wrong? It's not this. It's actually less. Now, there's statistically significant, and there's the practical significance of something. To be 73% versus 75%, come on. Give me a break. You probably wrote that so that it's easier for the human to reading a magazine. 75%, it's just easier than 73%, believe it or not. Make it something like 75%.
Can you do 30?
That's the other one, yeah.
On 6.6.
Yeah. So we'll try that one next. Any questions on this? It's definitely one of the weirder ones. So I understand if you do feel uncomfortable with it.
And how do we know that this is like, I don't know, it's called binomial or,
We know it's binomial because there were 2 possibilities. You use it or you don't. There's a certain number that they took. Right? So I have a probability of success using it, probability of failure not using it. Yeah, I can see those things. So on a test, what you're really asking is, when do I, and it should be kind of obvious. 11% of people like to go to the park. I think it's more, but I won't do that. And I take 90 people, and what's the probability? It's all shaping up to be N is whatever I just said, P is the 0.11, Q is the opposite. It's shaping up to be a binomial. I can tell it's a binomial.
yeah. So if we like did a study to see what the heights were of people, it would be the other.
Yeah, it would be binomial. It'd be continuous.
Continuous, yeah.
Yeah, and if it's it might be a normal distribution.
So we wouldn't use any of these formulas?
No, I wouldn't need to.
Okay.
I wouldn't even have what I needed to do it. Yeah, I wouldn't have to make my own mean and standard deviation. That's another key. If I don't give you a mean and standard deviation, it's probably not a normal distribution. It might be a binomial because that's where we make our own. We can calculate our own mean and
Or
standard deviation.
binomials.
Binomial can be normal. Can be approximately normal. No matter how good the approximation is, a binomial is not normal. It's not a normal distribution. It's just close enough. It's like this tells me the same thing as n greater than 30 tells me. You with me? This is a test, just like n greater than 30 is a test. Is it normal enough to use z-score charts to find areas? You with me? So I don't care if you take a sample of 8,000. Is that normal enough? 8,000. Is that normal enough?
Yeah.
Yes, good. Not a trick question there. I don't sound like it the way I was talking. But is it really exactly normal? I'll bet you any amount of money that it probably isn't. But it's normal enough. Cool. Yeah.
Can you go over 5 and 6 of 6.6?
I want to first do the number 30,
Yeah.
and then I'll go back. So keep that in mind. Okay. The nice thing with problems from 6.6 is it's a review of all of chapter 6. Because chapter 6 is making z-scores, looking them up. So 6.6 has that in it. It just has more stuff in front of that. So this is we're kind of reviewing all of 6 right now. So number 30. Says blah blah blah. Says a bunch of crap. So it says they have a polygraph. They want to see if the polygraph is something they can trust. They want to check it against random guesses. So we observed what?
15 out of 57.
Yeah, we saw 57 tests with a polygraph. We saw 15 false positives, right? And what's that mean in this case, false positive? What would that situation be?
Lies.
Somebody's hooked up, the machine says this person's lying, when in reality the person is telling the truth. That's a false positive. The same thing could happen if you go get an HIV test. They tell you you're positive, and it's a false positive. It's going to happen. No test is infallible. Right? So that's the idea here. A little less worrisome in this case, but still. That's the observed. We observed 15 out of 57. Now, what are we checking it against? What are we trying to see if this is evidence against what? We're trying to see if this is evidence against it guessing, randomly guessing. So what is that situation? If it was randomly guessing, what percentage of the time would it say you're lying versus telling the truth? 50-50, right? That would be random guesses, right? So P is 0.5, Q is 0.5. They do the same exact thing to test if people have ESP. If I have 3 cards, have you seen the ESP tests? Anybody ever seen the beginning of Ghostbusters? No?
Oh, yeah.
And they have the cards, and they normally have the rivers, the triangle, and the circle. At least those 3. And you put it up and you say, what card do I have? The circle. Well, and then you want to compare, well, if I was just randomly guessing, what's the probability of any of these, that I'm going to say any of these? 1/3, 1/3, 1/3, right? So I could make it, I could say it's a 1/3 chance of this, and a 2/3 chance of not that. With me? So I can kind of set that whole thing up. P is 0.33, Q is 0.66, and test it. And if they do it 80 times and I get it right 75 times, I can then see, is that enough evidence that I have ESP? Is what I observed different enough from what it would be that it's evidence that something weird's going on? You with me? Shoot, nobody said that. Does that make sense in any level at all? All right, so this is actually what happens. So here, we're checking to see if it's making random guesses. So we're going to say that situation would be 50-50 chance, right? And N, of course, is the 57. How many would I expect it to say if it was randomly guessing? How many false positives should I get?
28.5.
Yeah, so it'd be NP. I should get 28.5 false positives on average. With me? Okay, cool. And standard deviation of what?
3.775.
3.775. Okay, cool. Okay. So what's this? Is this normal? Can I say this is normal enough? Yeah, in this case, whenever it's 50-50, NP, I did it. What's NQ? Same thing, of course, yeah. So NP and NQ are both bigger than 5. Check. And again, let me put it down here. What does that really tell me? This situation is normal.
Wait, so would that mean that every time it's 50, it would be normal?
No, because N's got to be big enough, right? If I only took a sample of 4, half of 4 is 2, that's not bigger than 5.
Oh, okay.
Yeah, so in this, if it's 50-50, my N's just got to be big enough.
Oh.
Right? But in general, N and P together have to be something. That's why it's not the same as N greater than 30.
Right.
Good? Okay, good. Cool. Everybody, at least you're all looking this way. Makes you feel a little better. So what's this look like now? We know I can draw what here?
Normal curve.
Normal curve. Right in the middle is
28.5.
28.5. Now I'm trying to see if the 15, what I actually observed, if that 15 is unusual. So then it's down here. So the same idea as that last one. I want to see then, I can't just do the probability of exactly 15. That would not be fair. Because the probability of exactly anything all of them might be less than 5. Right? That's not fair. I have to look at the area that it's in. It's in the area down here. So I want to see what's the probability that it's less than or equal to 15. That's fair. If that whole area is weird, then anything in that area is weird. That's really the idea we've had the whole time. Anything within 2 is usual. Anything in the area outside of 2 is unusual. We said that from the beginning. Designating that outside area. The outside area. So what's that continuity correction going to do if I draw the inequality the right way? Draw the bar. Less than or equal to 15, do I want to include 15? Yes. So I don't want to start here then. I want to start there. So I shade the whole thing in the box included. So then I want to start at 15.5. So that's by the continuity correction. So now the beautiful thing about the continuity correction is the minute you've done it, you make a z-score, you look at the area, it's the same old stuff. Right?
How did you get 15?
So again,
How did you get the 15?
they gave it to me.
Oh, you did?
They have to tell me what was observed. Yeah. The really hard thing about these problems is they tell me both what's observed and what they think, what they're trying to compare against. And people get confused, which one do I use? People would, and this is a very common mistake, they'll use that for P. 15 out of 57, they say that's P. Well, that's assuming that that's normal then. You're making that the average. So will you ever show that this is weird?
No.
No, you will never show it's weird because you're assuming it's normal. No. You got to say, this is what I'm comparing against, and I want to see how that relates to that. Yes, ma'am.
I don't understand the part how you use 15.5 instead of 14.5.
Oh, 2 things on that. First off, you have to see why it's less than or equal to 15, and that's the whole idea of this area, right? So if it would have been up here at 38, then I want to be greater than or equal to 38. I want to see if that area including 38 is weird, so I would have started here. I would have started at 37.5. So it's too bad that both of these problems were down here. I'm glad you asked that question because then I can show you what would you do if it was up here. Same idea, here or up. So to include 38, you'd have to start at 37.5. Cool, I love it. So that's first to understand why this is true. And then of course the minute you got that set up, you just draw the box. Don't try to memorize unless you're really good. I don't have that much synapses left. I got stuff all crammed in my head. I can't memorize. When I see less than, I go down. When I see greater than, and then greater than or equal to is different. And then less than or equal to, screw that shit. Just draw the box, right? I want to be less than or equal to, so I want to start here, so I include it. So I start at 15.5. That took less than 10 seconds. I don't memorize anything. I just draw the box for the situation and think, do I want to include the box or not? So if it would have been less than 15, do I want to include the box?
No.
I'm going to shade this way, so I want to start there, so I don't include the box. So I make it 14.5. Again, less than 10 seconds to just figure it out. I'm not going to memorize something that would take me less than 10 seconds to figure out. I'm not going to memorize all that 4 different cases. Screw it. Unless you want to, and that's fine. So now I'm at the point where it's back to section 6.3. I make a z-score. I look up the area. And then I have to interpret it. So how do I make a z-score here?
28.5.
Careful. So it's
50
always my data point
minus
minus the mean. Good. Divided by
standard deviation.
standard deviation. So from that by itself, and I agree with you, from that by itself, I can tell that it's unusual. But trust me on this. There's a reason we want to do this. What would that area be then? This is negative 3.44. What's the area?
0.0003.
0.003. And that is obviously less than 5%, less than 0.05. So what does that really mean physically? It's really easy to get wrapped up in all the math, and I totally understand it. So that by the end, you're like, it's just freaking numbers. You know, I don't know what the hell these numbers mean. So you go back and you say, all right, was it making random guesses then? If it was making random guesses, this should be true. But what we did, we observed something that was so far away from what should have been, are so unlikely if this is true, right? If this situation is true. So what's more likely is it's not true. It wasn't 50-50. It's not making random guesses. You with me? If it was making random guesses, it should get 50% false positives. And it didn't get 50% false positives. It got well below it. Whale? Whale? All right, hopeful. That problem is like a culmination problem. It's just the capstone on chapter 6. It's everything that you saw in chapter 6 all together, plus a little bit extra. Right? The interpretation at the end especially. So if that's the only kind of problem you're having trouble with, it kicks ass. You're going to be fine. Trust me. All right, so where do you want to go next? I think, Patrick, you had a question? Then
5 and 6.
5 and 6 from the practice test? Is that what you mean?
5 and 6 from the 6.6.
Oh, 6. Did you guys ever hear that, real quick while I'm thinking about it, because we just were talking about ESP. There's a group of people that will pay $1 million for evidence of ESP. And they have this test, pretty much exactly the same test I just told you about. That you can come in, sit down, they'll run the test with you. If it's statistically valid evidence that you have ESP, they will provide $1 million. They want.
What is ESP?
Yeah.
What is ESP?
Second powers.
Extrasensory perception. Where you go? Somebody's in trouble. You don't need Lassie to come. No, Lassie already knew it. And I was like, oh, shit, I'm just gonna go somewhere else. I'm not even. So ESP is just that extra sense that something's wrong, or people think of it like there's a lot of different components. So anyway, I'm going to get into it. But look it up. Look up ESP, $1 million. And if you think you have ESP, go collect your money. Let's see. So 5 and 6. This is page 294. So this one says, describe the region of the normal distribution that corresponds to the indicated probability. Oh, okay. So this one is kind of funny. When you read the directions, it's a little bit vague, but all they want you to do is apply the continuity correction. That's all they want you to do. So it says, probability more than 8 senators. So I can write that. So are we cool with that? Probability more than 8 senators. Right? So to do the continuity correction, you can just look at 8. That was suspenseful. More than 8. Do I want to include 8? Do I want to include 8?
No.
And which way am I going to shade? Up. So if I shade up and I don't want to include 8, I obviously don't start here. I start here, and that would be 8.5. Now, can you say it in words then? What would the area be? The area is
To the right.
to the right, greater than 8.5. I love it. To the right of 8.5. So in words, you would say to the right of 8.5. But to be completely honest, if you just drew that picture for me and shaded it in correctly and put the right number there, you're saying the same thing to me. So I love it. Either way. In English or visual. I'll take either one. You guys
And
said
that's all
my
it wants.
That's all it wants. So if I said the probability that at most 15 people don't show up for their plane, for their flight, what would the continuity correction be here?
15 and
Include 15, include 15.
14.
Do I want to include 15?
Yeah,
Yes. And which way am I going to shade?
left.
Down. So if I start here, that sucks, because I didn't include. I want to include 15, so I start at 15.5. So if you did exactly that, if you just drew this picture, beautiful. Cheer. Or you can say to the left of 15.5, below 15.5. Any variation thereof. I just got to use the word thereof. Yeah.
I have a question on the practice test,
Yeah.
which
Hopefully.
is number 4.
Good. That's what I actually have.
I just don't know find the z-score bounding the middle or anyone. I didn't know what bounding meant.
Oh,
Yeah, that's the-
That was the only thing that I really didn't.
yeah, not like bounding through the field, but
I had no idea. I know what the word means.
bounding like they're the bounds of the middle. So if I ask you, where's the middle 81% on that picture? Can you draw lines in there showing me the middle, what was it, 80%? 91%.
So like, are you looking for 91.5 or?
No,
Okay.
don't overthink this.
Okay.
Where's the middle 91%?
It's in between the.
Yeah, so here's the mean, so the middle 91% would have 91% in there. So what's gonna be true about those two z-scores? If this is negative 2.7, can anybody tell me what that would be?
Positive.
Positive 2.7, because of the symmetry. So the middle 91%,
Wait, why would it be 2.2?
I'm just saying if it was.
Oh.
I don't know yet, because we haven't done it yet.
Oh.
Now, the problem people have with this, would you look up 0.91? If you look up 0.91, you're finding this z-score.
But they do want that.
We can't
Right.
just divide
Well,
by
that's,
two.
no, that's the first part.
Oh yeah, I know, so that's part A.
That's part A.
And that's the easy part, hopefully.
Yeah, I did that.
Right, look up
Yeah.
0.91, you're done. Because
Yeah.
91% below it, that's exactly what the chart tells me. Look up 0.91, where would you look up 0.91? 0.91? No, you gotta look in the middle. Because what is 0.91 in this case? It's an area. What does it look like, this stupid little thing? Looks like a frickin' z-score. Evil. You kind of with me. Be really careful. Put areas up here for yourself. Put z-scores down here for yourself, so you know which one's which when. Is everybody actually cool with part A? I don't want to skip that by. If you look up
I got
0.91,
1.34.
what's the closest area to 0.91?
It's 0.9099.
Yeah,
1.34.
it's pretty damn close.
Yeah.
So 0.9099, almost right dead center of the negative, positive z-score chart. And if you look at what z-score that represents, 1.34. So a z-score of 1.34 has 91% of the normal distribution below it. That's what that means. How we do? Decent, okay, I like it. So here, the problem with this one is the chart only understands areas that are below a z-score. So I could find this z-score first. What area is below it? What's outside of here?
4.5.
Yeah, so there's 9% outside, so there must be 4.5% down here.
Okay.
Do you guys get that?
Yes.
You've got to take the area I give you and find the area that's actually below a z-score. That's the only thing the chart understands. You look at 0.91, you're not going to be doing this thing, you're going to be doing that thing. Wrong answer. You've got to relate to this. So that z-score, if it's on the side of this that has 91%, it's got to have 4.5% below it. So if I look up 0.045, I'm finding the same z-score that this describes. Those have to be true. If that's true, this must be true. And what's the closest you get to
For that
0.045?
one, I got
1.7,
negative
1.70.
1.7.
1.70.
Let's see, 0.045.
1.70.
I see.
Negative
Yeah,
1.9.
1.69 is 5 away,
Oh, negative 1.7.
whereas 1.70 is 4 away. 1.69 is 0.0455, and 1.70 is 0.0446. Which one's closer to 0.045?
1.6.
This one, 'cause it's only 4. Now, some of you guys, it'd be cool if you split the difference and made it negative 1.695. But you don't have to. Just take the one that's closest. The closest one is that one, and that's the negative 170. So what's this do?
Same thing.
1.7.
Positive 170.
Okay. I don't think we learned that.
Yeah. So then we just.
Yeah, we did.
I vaguely remember that.
We learned that. We learned a lot of stuff that I could ask you about that you could say we never did a problem like that, but we learned it. We learned how to do these kind of problems. Right? If I said find the top.
Well, I think just the concept of bounding
Exactly.
the area.
If I said that,
I don't think,
okay.
I don't think we went
That I
over
can understand.
Yeah.
But if I said the top 5%, you actually have to look up 95%.
Uh-huh.
So if I said the middle 91%, you actually have to look up 4.5%.
Yeah.
Right, to find it. Yeah.
If you were to put 1.69, would you mark it wrong?
You wouldn't lose a ton of points, if any. Yeah. This one I might be a little nice because it's so close either way. But you really, either you have to split the difference or take the one that's truly closest. Cool. But I wouldn't be on it, I'm just totally wrong. Notice myself just keep losing then.
You have the answer sheet for this?
Yes,
Oh.
I'm going to give that to you.
Thank you.
Let me say this. At some point in the recent past, I changed this test a little bit. So number 6 is a little bit different. Or I'm sorry, on yours is number 7. You'll see what I mean here in a minute. Just so I can get this class on time, I had to have my 2 printers printing out. Here's the first side, and then I'll give you the second side. Lost count, so it's probably- Don't worry, I'm going to give you the first side, and then I'll give you the second side.
Can you do number 5?
Sure. Yeah, give me a second. Do you notice how there's a slight difference on the first page?
On the first page?
You see the box plot problem on here?
Yes.
You do?
No.
Okay. I was going to say neat.
Only one page.
Don't worry. I'm giving you the first page, and then I'll give you the second.
Take off this number. No, okay.
So I had to, in the recent past, I had to include that box plot problem. Because in the last few semesters, I've had to push that 3-4 section to the next test. So on this answer key, there's not the box plot problem, so we can do that one together. That might be a good one to do because it's so long ago anyway.
Yeah.
So I'm gonna make sure everybody's with me on this. And I will admit, this is not me quite being lazy really. I've just not had the most time in the world. Good. You need the first one? I was gonna make a new answer key, but then I thought, oh yeah, I've got the answer key at school, so when I get there Monday morning, I'll just make some copies. Of course, first it took me forever to find it, and then when I found it, I'm like, shit, it's not the same. And then by that time, I didn't have time to make a new one, so please forgive me. And if you don't forgive me, too bad. But there's no box plot problem. So on the second page, the numbers are off by 1. Don't freak out. Your number 7 is different than the number 8, and who cares? Because neither one would be on the test anyway, so you can cross that out. And number 6, unfortunately, at some point, for some reason, I changed it from 88% that you see in the answer key to, I think, 93%.
Oh.
So just point that out to yourself. In number 6, you see how to do it, and then you can try to do it with the 0.93 to see how it comes out. We can do that problem too if you want to have the right numbers.
You said which ones were in the other test?
Number 8 on your blank practice test, and number 7 on the answer key.
Okay.
They don't match up, but it works out for me because they're not going to be on there anyway.
This is 23 and it's 23, so.
Yeah, there's a couple differences there. Okay. So let's first maybe do the box plot. All right. So I'll go against what I said earlier. We'll jump all the way back to section 3-4 and get that kind of taken care of now.
Wait, is this gonna be the test though?
Oh hell yeah! Yeah, I haven't tested you on that yet, so it's on this next test. Patrick?
So 8 plus 7 not to be on the test.
Yeah. So 8 on your blank practice test? 8 on your practice test?
Yeah.
7 on my answer key. Right. Why are all the numbers off by 1?
So
Because I
8
have that box plot
confused,
problem.
So 8 would not.
Good. 8's from chapter 7. It's gonna be on the next test after this one. Cool. So let's do number 5. The one that threw off my numbering on the answer. What's that?
I guess that is me, the Z score is 5.68, and it's at 20% here.
5.68, about 0%.
Oh, about 0%, I thought it was a 2.
No. So that's like an
I
approximate.
was like, how is it
It's like a
20?
0 plus.
I was like, there's no way that's 20%.
Yeah. Then you're allowed to slap me. So number 5. Now what's the first thing you want to do with number 5? Even before you even
Sort it out.
Yeah, sort the thing. So you can put them in list 1, sort them. So can at least one person do that for me?
208, 209, 106, 210.
All right, so keep those in mind. So sorting it should be easy. Hopefully everybody can sort a list of data. The true difficult part of this problem would be the work. And you've got to show me the work. What's the beautiful thing though about checking your work? How do you check your work? What is the 5 number summary? How can you get the calculator to give that to you? 1 var stats. Scroll down, it's the very last thing. The last 5 things are low, Q1, Q2, Q3 high. That's the 5 number summary. That's what you need to make a box plot, right? Cool. So the low here,
208,
208,
maximum 239.
and the high,
239.
239. So you just sort all this, or you can just pick it out as you go. Now, how do I find Q1? What is Q1 also known as? P25. So then what are the 2 steps involved to finding what that is?
You add up, you add up it. You count and you add up it. Divide by
How
two.
far into the list do you want to go? You want to go halfway into the list?
Yeah,
You want to go 1/4 of the way through the list. You want to go 25% of the list length in. And what's the list length? How many numbers? 16? So 1/4 of 16 is 4. And what does that mean? Average the 4th and 5th.
Oh, right.
So step 1, it's not get a box. Step 1 is where's the answer. Step 2 is go get your answer. Right? So we just figured out the answers in between the 4th and 5th numbers. Abdullah, help me out. What are the 4th and 5th numbers? Do you have it in order?
Yeah. 4, 2,
Say it again?
211.
211?
Yeah, and 211.
Oh, 211?
Yeah.
That's a kick-ass average. 211. All right. So Q1 is 211. And then Q2, you find it the same way. Q2 is P50, also known as the median. So you go 50, you go halfway in, and that of course is 8. And what does that mean? 8th and 9th. So average the 8th and 9th.
218,
218 and
222.
222.
Mm-hmm. Yeah,
Should be able to just look at 218, 220, 220s in the middle, but you can average them and you get 220. So Q2 is 220. I'm going a little fast, but it's the same thing over and over and over again. Is everybody doing okay so far? Yeah. You remember this stuff? Yeah. Q3, P75, 75% of the way in. 3/4 of 16 is 12. So you take 12th and 13th, which are
229, 234,
234,
231.5.
231.5. Now, the main mistake you guys made on the quiz, because they did a quiz with box plots a while back, remember? The main mistake people made was the scale. You can't base your scale on these numbers. Right? If you did that with a graph, you're graphing data you find, you're always going to get a straight line. Of course you will. Your scale has got to be consistent, independent of these. You have to find these in it. So a good place to start then would be 210. No, it's not, Jeff. 205. Keep looking here. I want to include 208 in there, so it's good to start at 205. And I want to get up to 240, so going by 5 seems to make sense. I don't have to turn my paper sideways to fit that.